So this is the explanation to our friction puzzler about skidding cars. So the first thing to be aware of is that the two kinds of friction, static and kinetic, can be thought of as rolling friction and sliding friction, respectively. So let's take the easier case first. If a tire, this is my tire, let's pretend that the tire is skidding across a surface, right? So remember, see how it's not rolling there? If the tire is skidding, we would say that because the two surfaces are moving relative to each other, that is kinetic friction. Remember, kinetic friction is always less than the maximum value of static friction. So what's the story with rolling? Well, I just want you to keep your eye on this piece of blue tape. Moment by moment, as the wheel rolls, that blue tape and every other point of contact, moment by moment, is stationary relative to the tabletop, okay? In other words, yes, the wheel is moving, but because the wheel is not skidding, the friction between the surface and the tire is in fact static friction each moment. So we would say that rolling friction is static friction, and that value is generally higher than, the maximum value is always higher than the kinetic friction. So what does that have to do with our little puzzler? Well, I just want to remind you what we observed. So you've got a cart with a friction pad in the back. So that's going to be the skidding wheels, or the little felt pad is the skidding wheels in the back. And this is my cart with the skidding wheels in the front. So I've got kinetic, so for my yellow cart, I've got kinetic friction in the front. I've got static friction in the back, right? Sliding friction in the front, rolling friction in the back. Let's see what happens. Okay, that cart goes in a straight line. But now when I've got rolling friction in the front with my rolling wheels and sliding friction in the back, my car always turns. So we're going to use these arrows to represent kinetic and static, or sliding and rolling friction. Okay, rolling is the bigger, sliding is the smaller. Okay, so let's go back to the yellow cart. If I have the sliding friction in the front, that's the smaller arrow, and I've got the rolling friction in the back, okay, as the cart moves forwards, I've got a smaller force in the front and a larger force in the back, and the cart just gets pushed by friction this way as it moves that way. On the other hand, with my cart that has the rolling friction in the front, I take the larger amount of friction and I put it at the front of the car, and I've got my smaller amount of friction in the back. That is going to try to yank the car around so that these two forces of friction switch place. Okay? Let me say that again. If the larger friction is in the front, that force is going to kind of win out over the back force, and it's going to slow the car in the front faster, and then the back of the car is going to swing around. Well, why do we care about this? We care about this because when a car is trying to stop very fast, like if you're trying to avoid an accident, it's critical that you can control the direction of the car. So to that end, we want to make sure that the wheels of the car never lock. We want to make sure that the wheels of the car don't lock up into kinetic friction, because this is a weaker amount of friction. The technology in cars these days for that is called anti-lock brakes. So anti-lock brakes, when you start to drive, if you ever slam on the brakes of your car, you'll feel the electronics pulsing the brake system. So rather than allowing you to lock the wheels, the electronics will turn the brakes on and off like probably 10 or 20 times a second, so that the wheel is always technically rolling, which gives you a better control over the car. The other technology that is involved is called braking power distribution. So the electronics of the car essentially can control the amount of braking power to the wheels so that the wheels never lock up, and you never end up in a situation where the rear of the car is going to whip around to the front. Okay, this was actually really problematic in the 1950s and 60s when cars were almost exclusively rear-wheel drive, because when cars deliver all their power to the rear wheels, the braking power is also mainly in the rear. So if you look at videos from car crash tests in the 50s and 60s, you'll see that cars always yank around. And so then automakers started to use what we call front-wheel drive, so that the braking power was heavier in the front and cars could skid in a straight line. Of course, with anti-lock brakes and electronics managing all of the power distributions in modern cars, that's less of an issue. So this little friction puzzler is a great way to apply your knowledge of static and kinetic friction, which in our lab this week seemed simple, but then has lots and lots of applications. Thanks for watching.